Hi and welcome to this video where I'm going to discuss amides, how to identify and some of the key reactions. So the first thing to be aware of is that amides are like a combination of an amine and a carboxylic acid. So it's a carboxylic acid derivative. So if you can picture a carboxylic acid, you've got the double bond O, the OH. If you take away the OH and put on a nitrogen group, an NH2 or similar, then you have a amide. Now amides come in primary, secondary and tertiary varieties, and you need to be able to recognise all of those. So let's have a quick look at those first. Okay, so these structures show you your primary, your secondary and your tertiary amide. All of them, you can see, have a carbon with a double bond O attached to a nitrogen. The difference between them is that the primary has 2 hydrogens on the nitrogen, the secondary has 1 hydrogen in a carbon chain, and the tertiary has 2 carbon chains on the nitrogen. So when we determine whether it's primary, secondary or tertiary, what we're actually looking at is how many carbon chains are attached to that nitrogen. So the primary, you've just got that 1 carbon chain attached with a carbonyl group on it. The secondary, you've got 2 carbon chains attached, 1 with the carbonyl group and 1 as a chain. I've just drawn 3 dashes off each of the carbons because they could be connected to other carbons, to hydrogens, it doesn't really matter. And of course the tertiary, we have 3 carbon chains connected to that nitrogen. So the next thing is all about naming amides. Now, you need to be able to name primary amides. You don't need to be able to name secondary and tertiary amides, but you do need to be able to recognise them. All amides are named as something or other amide. So methane, ethane, propane, butane, etc. amide. Just like a carboxylic acid, the amide group is always located on the end of the carbon chain and is always number 1. So you don't need to number the amide group, you just need to include it in the name. So let me show you a couple of examples of amides and how to name them. Okay, so here we have 2 amides. If we look at the one at the top first, that's the simplest one to name. So just like any other naming system, you're going to start off by identifying the longest carbon chain and count it. So here we have 3 carbons in a row. 3 carbons is prop. They are bonded together with single bonds, so we're going to call that an. AN. There could be a double bond in there potentially, in which case you'd have an EN, but this is propane and it has an amide functional group on the end, so we're just going to write amide. Propane, amide. Nice and straightforward. The second one's slightly more complicated, but again, if we look at the longest carbon chain, we have 5 carbons. 5 carbons is pent. And the bonding between the atoms is single, so we're going to have an AN. 1, 2, 3. It's got an amide group on the end, so we're going to call that amide. And then we have this methyl group. So we need to count how many carbons along we are, starting from the carbonyl carbon. Yeah, this one here. 1, 2, 3. Okay. 3 methyl pentane amide. And that is how we name our amides. Very straightforward, nothing different to what you've come across before. Okay, so people often get confused between amines and amides, and I know the name doesn't help. So I'd like to quickly give you some information about how to compare the two. So first off, amines don't have a carbonyl group, okay, whereas amides do. They both have nitrogens, and they can both be classified as primary, secondary or tertiary based on how many carbon chains are attached to the nitrogen. Here's some key differences though. Amines are bases, they're basic. That's one of the key things about an amine. But amides are neutral. Okay, they're not acidic or basic. Amines are liquids at room temperature and they tend to smell like fish, whereas amides are solid crystals at room temperature. They're both reasonably soluble in water if you've got short chains, but not so much for longer chains. Just like all the other organic compounds, solubility decreases with increasing chain length. Okay, so in terms of reactions, amides are not particularly reactive. In fact, they tend to be quite stable, which is quite a useful thing sometimes, but they're not particularly useful in terms of conversions from one molecule to another. They are neutral, so they don't exhibit that basic character that amines have, and in fact they don't really do anything much with water at all. The only real reaction they do is what we call hydrolysis. A hydrolysis is a reaction that splits the amide back into its carboxylic acid, and amine must be done under acidic or basic conditions, and I will talk about hydrolysis reactions in a distinct video because it is quite an important concept that needs to be covered in and of itself. That is the key ideas associated with amides. They are carboxylic acids where the OH has been replaced with a nitrogen group. They can be primary, secondary, or tertiary. They're named as such and such an amide, and they tend to be fairly unreactive. Okay, well, thanks for watching. If you've got any questions, please don't hesitate to contact me, and I will see you in the next video.